We'll begin with ellipses. So just a quick recap, we've done vertical parabolas, we've done horizontal parabolas, and we've done circles. The most difficult part of the exam coming up is you're going to add to that ellipses and hyperbolas, and they're all going to be mixed up. So it's going to be you trying to figure out which equation goes with which graph and going from there, okay? So today's material, we start with ellipses. These are kind of football-shaped looking things, maybe something like this, or it could be more vertical, okay? Or even a circle is also an ellipse. But these are the types of graphs that we're going to be doing, okay? Now for ellipses, the first thing that we need to know is, other than the football shape, the equation. So it looks like this. X squared over a squared plus y squared over b squared is equal to 1. Okay, so we need to memorize the form of the equation first. The x squared and the y squared are going to be variables, but the a and the b are going to be numbers. Okay? And a couple of things. How do I know what the graph looks like? Well, this graph will have x-intercepts at the a value, so a0 and negative a0. Those will be your x-intercepts. And your y-intercepts will be at the b values. 0, comma b, and 0, comma negative b. Okay, so that'll tell us exactly where to go. Roughly, our sketch is going to be these 4 points and just kind of fit a football shape with those 4 points. Okay? So that's kind of how we approach these ellipses. Now, as I mentioned before, all of these are going to be mixed up on your final, on your last test. So it's really important that you start memorizing a few things. And one of the few things to memorize is both the x squared term here and the y squared term are both positive for ellipses. Okay? So you might want to put that in your notes. The x squared and y squared term are both positive for ellipses. Okay?
Is it for all 3 of these or one of them, you said? For the football one, I meant.
Oh, those are all ellipses, yeah.
Okay.
Yeah. And so again, the x squared and y squared terms are both positive for this graph. Okay, let's jump right into one. I'll start off with an easy one. X squared over 9 plus y squared over 16 equals to 1. The reason why this problem is so easy is because it's almost perfectly in this form. Almost there. There's only one little tweak that we would need to do to get this to look exactly like that. And what would that tweak be? Instead of 9, you would write 3 squared, and 16, you would write 4 squared. If you do that, then it'll look like this exactly. Okay? So let's write 9 as 3 squared and 16 as 4 squared. So let's look at it like that. Okay? Now you instantly know where the x-intercepts are and where the y-intercepts are, and then all you have to do is graph it. Okay? So once I put it in that form, what are my x-intercepts? The 3. The value under the x is 3, right? So I'm going to go out 3 and negative 3. So 1, 2, 3, and 1, 2, 3. And my y-intercepts, the number underneath the y, is 4. So I'm going to go up 4 and down 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? So again, this is stuff that we're memorizing today. The 3 that corresponds with the x, those are your x-intercepts, plus 3, minus 3. The 4 that corresponds with the y, those will be your y-intercepts, plus 4, minus 4. Then fit a little football-shaped looking guy through here, and that's it. It's as easy as that. That's our ellipse. Now I say it's as easy as that because that one was already in the form. Okay? The problem that you're going to have is it won't look just like this. So we're going to spend a few minutes getting it to look just like this. Then once we have it in this form, boom, we can put it into the graph. Okay? All right, let's do a few examples. So let's get you started with this one. Nine x squared plus 25y squared equals 225. Okay? Well, you notice we have the x squared and the y squared terms on the left side already, so that's good news. But the 225 on the right, what is on the right for a perfect form for an ellipse? What number? 1, okay? So to get a 1, what I'll have to do is divide each of these by 225. Because I got to get that 1 on the right-hand side. Okay? Because I'm trying to get it to fit that form exactly. So now I have a 1 over here. Now I need you guys to help me out. We're going to have to see how many times 9 goes into 225 and how many times 25 goes into 225. Okay? So go ahead and do that. You can break out a calculator. 9 into 225, how many times? 25 times. So you're going to get x squared over 25 for that first term. How many times does 25 go into 225? 9. Great. So y squared over 9. Okay. Question?
Why can't you divide the numbers with 25 and 9? Why do you have to use 25?
So if you look at the standard equation for an ellipse, there's a 1 on this side. So you need to get a 1 there. So if there's a 225, dividing by 9 and 25 is not going to get a 1 over here. What's going to get a 1 over here is dividing by 225. Yeah. Okay.
I'm confused. Like, how is it 25 there? It's not making any sense for me.
Okay. So is everybody okay that I divided everything by 225, these three terms?
Yeah.
225 divided by 225 is just 1.
I know, but
These I have to factor, right? How many times does 25 go into 225? I'm trying to figure that out. So I'm reducing this. 25 goes into 225 9 times. Okay. And here 9 goes into 225 25 times. I'm just reducing since they're all being multiplied. Okay. Now, to put it in exact ellipse form, you get x squared over 5 squared plus y squared over 3 squared equals to 1. Okay? And again, what you need to memorize is the x's go with the 5s and the y's go with the 3. So now you can graph it. Okay? So I'll do a nice little graph over here. The x's, I'm going to go out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the y, I'm going to go out 3. 1, 2, 3. 1, 2, 3. So it's kind of a sideways looking football. Okay?
Sir,
Yes?
how are you getting this football?
Well, all ellipses look like a football. Okay, so I need to memorize that. And then it corresponds with how many places I go out. My y-intercepts are 3. So I literally go up 3 and down 3. Those are my y-intercepts where it crosses the y-axis. My x-intercepts are 5. Okay, because when it's in this formula, we're given the intercepts. So I go out 5 on the x, 1, 2, 3, 4, 5, and out 5 on the x here. Okay. Okay, x squared plus 9y squared equals 9. What do I do first? Divide by 9. Why? To get a 1. When I do that, I'm going to have x squared over 9. Here the 9's cancel out. Y squared over 1 equals 9 over 9, which is 1. That's your first step, okay? Assuming that you already have the x squared and y squared on the left side. If that's not there, you need to add to get those over there. Now, to put it in perfect standard form, you'll write it x squared over 3 squared plus y squared over 1 squared equals 1. Okay? Now we're perfectly in the ellipse standard form. Can you tell me how many places I need to go on the x-axis and how many places I need to go on the y-axis? 3 on the x, so let's do that first. And how many on the y? 1. Pretty easy, right? That's it.
Are we going to be learning about the cases where we can't get rid of the numerator?
No.
No.
So you'll be able, if it is an ellipse, you'll be able to get it into this form. Problem is it might not be an ellipse. It might be a circle or a parabola, so we'll have to work on that.
So in the ellipse, right, is football.
Mm-hmm.
Operators always cancel out, or is it?
No, it's not that they cancel out. It's just that you can put it in this form. So sometimes you might get weird numbers, like it might be the square root of 7, right? And so you'd have to estimate, oh, square root of 7 is approximately here. Yeah. These numbers have been all really nice so far.
Could there ever be numbers like 5x squared plus 3y squared? Or would it always like cancel out the top?
If it's an ellipse, we can put it in this form. If it's something else, it'll be something else. Yeah. Yeah, good question. Okay, what about x squared plus y squared equals 4? Go ahead. Put it in form and graph it for me. And tell me what you get. What did you guys get? Yeah, it's a circle, right? We just go out 2 on each. So where's the center of this circle? 0. Does that correspond with our circle formula? What is our circle formula? X minus h squared plus y minus k squared equals r squared. It's the same formula. So notice, this formula, you could do it in terms of an ellipse, which is fine, but it also works as a circle. So circles are ellipses too. Okay? But either way you do it, if you recognize it as a circle, you'd get the exact same graph.
Question. There's ellipses, and then is it horizontal, or is it something else where you have the minus x squared minus y squared?
It's hyperbolas, which we're about to do. Yeah.
You can't use the second equation if the x-axis or the x-axis and y-axis are different, right?
Right. So if I had like an actual number here, you wouldn't be able to use this formula. You'd have to recognize it as a circle. Okay?
Or like the circle goes
Yeah, it might be over, squished in another place. Okay, hyperbolas now.
Is that 13.3?
Same section.
Okay.
Okay, hyperbolas. First, here's what they look like. They could open, they kind of look like parabolas, 2 parabolas. So you could have it opening north and south, okay, up and down. Or you could have it opening left and right. So you're roughly going to get one of these pictures. Okay? These are both hyperbolas. The equation of a hyperbola is very similar to an ellipse, except one of the terms is negative and one is positive. With the ellipse, the x squared and y squared terms were both positive. Here, one of them is going to be negative. Okay? So you could have x squared over a squared minus y squared over b squared. Okay? Depending on which one is positive, here the x is positive. So you're going to have x-intercepts, and it's going to go left and right. So this guy goes with this picture. Okay? It has x-intercepts. Does everybody see why there's x-intercepts? Where are they? X-intercepts, right? And it goes left and right. So if the memorize this. If the x squared is positive, you have x-intercepts, and it goes left and right. And those x-intercepts are at negative a and a. Okay? The other picture that you might have is if the y squared term is positive and the x squared term is negative. This one's going to have y-intercepts because the y squared term is positive. So this guy goes with this picture. y-intercept here and here. So 0, comma b, and 0, comma negative b.
So the y is
Yeah, so if the y is positive, you get the up and down graph, and the intercepts are with the b, right? What's under the y? Okay, similar to an ellipse in that point. And if the x is positive, you get left and right, and the x-intercept is the a. Okay? Okay, the extra portion is we have these asymptotes. And the way you generate these asymptotes is by extending diagonals. Okay? So both graphs will have asymptotes at extended diagonals of rectangle with the points, every combination. So you'll have AB, negative AB, negative A, negative B, and A, negative B. So every combination of A and B, positive and negative. Whoops, lost my mic. Every combination. Okay? So let's do an example together, so we can see how it works. Y squared over 4 minus x squared over 25 equals to 1. Okay. So the first thing I would like you to do is put it perfectly in standard form. And then after that, tell me which one of the hyperbolas it is and how the graph looks. Let's just do that first. So instead of 4, I'm going to write 2 squared. Instead of 25, I'm going to write 5 squared. So which of the hyperbolas is this one? Up and down or left and right? Up and down. How do you know? Because the y is positive. Okay? So the first thing that you're going to do is you're going to draw a graph, and you're just going to put your y-intercepts at the 2 and negative 2. So far, you know your graph looks like this. Okay? We have y-intercepts, because the y is positive, and we know it's going to open up and down. Here's how you do your asymptotes, which are the extended diagonals of your rectangle. So every combination of 2 on the x and 5 on the y. Okay? Oh, I'm sorry. I said that backwards. 2 on the y, 5 on the x. Okay? So 5 on the x, 1, 2, 3, 4, 5, and up 2, there's 1 point. This is 5, comma 2. 5 on the x and down 2. This is another point. 5, negative 2. Negative 5, 1, 2, 3, 4, 5, and up 2. This is another point. So this is negative 5, 2. And 1, 2, 3, 4, 5, and down 2. This is another point. Now, they're not part of the graph, so I put x's there instead of points because it's not the actual graph. This is to get our asymptotes. Okay? So going through the center, 0, 0 here, you're going to extend these diagonals. Okay, and that would keep going. And extend this diagonal. And this is how you graph these guys. Okay? So extend the diagonals of the rectangle that you just created. And so your parabola-looking shape is going to go toward those diagonals, get closer and closer and closer without touching. Okay? So this graph gets closer and closer and closer without touching. And that's what your hyperbola is going to look like. Okay, so that one's pretty wide, vertical hyperbola. Questions on this one? So all the things that we've been doing, memorize which one's positive. That's the intercepts that it corresponds with. Then drawing the extended diagonal is how you get your asymptotes. Yes?
There's no like exact curve, it's just however you can get close to it there. Kind of.
Yeah, so there's a, I mean, for us to sketch it, this is the best we can do. Yeah. Okay, let's do one that's not in standard form that you guys need to put in standard form. Okay, let's try this one. 9x squared equals 144 plus 16y squared. Okay, take a couple minutes. See if you can put that in standard form, and then see if you can graph it for me, and then we'll check it together. Okay, let's go over it. What did you guys do first? Awesome. Subtract 16y squared. And then what? Divide by 144. That gets that 1 on the right-hand side. What do we get on the left side? X squared over what? 16? Minus y squared over 9. Great. And I would probably write that as 4 squared and 3 squared. Okay, which type of hyperbola is this? Side to side, left and right. X is 4 and negative 4. So I'm just going to do a quick rough sketch here. I'm going to go out 4 and negative 4. 1, 2, 3, 4. 1, 2, 3, 4. And the y value is 3, right? 1, 2, 3. 1, 2, 3. Great. So I put x's here, 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 here. Diagonals like this. And you guys should have got something like this. Quick rough sketch. Everybody get that? Great. Okay, here comes the hard part. On your test, there's going to be a big section that's going to ask you what type of graph it is, and then to graph it. Okay? So, what graphs have we done? We've done lines. We've done parabolas. We've done circles. We've done ellipses. And we've done hyperbolas. All of these are on your next test. So it's going to be about you identifying which type of graph it is and then figuring it out. Okay? All right, I'm going to put a bunch on the board. I'm going to give you guys a few minutes to work on these, and then we'll go over them together. So the first one, 9x squared plus 25y squared equals 225. Number 2, y squared equals 4 plus x squared. Number 3, y equals x squared minus 9. Number 4, x squared plus y squared equals 4y. Number 5, 9x squared equals 16y squared plus 144. Now, what I would like you to do, I want you to go through and identify each of these. Okay? Give me the characteristics of it and what the graph roughly looks like. Okay, so take a few minutes to do that, and then we'll go check them together. So identify what type of graph it is, and see if you can give me characteristics and a rough sketch. So I'll give you some time to work on that, and then we'll go over them. Quick recap, lines. You might have y and x in an equation, right? Y equals mx plus b, or y equals a number, or x equals number. But you won't have any squares. There won't be any x squared or y squared term. Okay? Parabolas. You're either going to have y equals ax squared plus bx plus c. So you have y equals x squared. That would be a vertical parabola. Or if you flip them and you get x equals y squared, that would be a horizontal parabola, right? Okay. Now, if you look at all of these today, they all have x squared and y squared, except for this one, number 3, right? That one has y equals x squared minus 9. So what is number 3? It's a parabola. It's a vertical parabola. How do I know it's vertical? A is positive, right? Y equals x squared minus 9. I could go through my 4 steps for graphing a parabola. But roughly, we know the intercept here is 0, negative 9. And that's a pretty good rough sketch. Obviously, I would want a better sketch on the test because I would want you to go through x-intercepts, y-intercepts, axis of symmetry, vertex, right? So number 3 is a parabola. Number 4, notice number 4 has a 4y term. Okay? None of the stuff we did today had any x or y term that wasn't squared. Right? Ellipses and hyperbolas, they were in that standard form and there wasn't an extra term. This guy had an extra term. Okay? So what is this guy? Well, if I start bringing stuff over, do you guys remember circles? How do I put circles in standard form? What's that process called? Completing the square. Half of 4 is 2. 2 squared is 4. So I needed to add 4 to both sides of this circle. I would have needed to recognize that that was a circle. Okay? And then in standard form, I'll get x minus 0 squared plus y minus, what's that? What's y squared minus 4y plus 4? Y minus 2 squared equals 2 squared. That's a circle. What's the center of that circle? 0, 2. And what's the radius? 2. Okay. You have to remember all of that stuff from before. Okay. X minus 0 squared plus y minus 2 squared equals 4, which is the radius squared, 2 squared. Yeah. Can you see it? Okay. So number 3, parabola. Number 4, circle. The rest of these are what? What we did today. Ellipses and hyperbolas. Okay? Okay, what's number 1? What did you guys do? Yeah, it's almost in perfect form. You divide it by 225, and what did you get? X squared over?
25 plus y squared over 9.
That's an ellipse. What are my x-intercepts? 5 and negative 5. What are my y-intercepts? 3 and negative 3. Okay, great. That takes care of number 1. What did you guys do for number 2? Minus x squared. So you have y squared minus x squared equals 4. Then what did you do? Divide by 4. And so you get y squared over 2 squared minus x squared over 2 squared equals 1. What is this? It's a hyperbola. Does it have x or y intercepts? Y intercepts. So does this move up or down or left or right? Up and down. Okay. Number 2 is a hyperbola. And last but not least is number 5. Let's make some room for number 5. What did you guys do for number 5? Subtract 16, right? Get it in standard form. So you have 9x squared minus 16y squared equals 144. Divide everything by 144. 1 second. Let's get through this. And tell me what you get in standard form. X squared over?
4 squared.
Okay, 4 squared minus? Equals 1. So hyperbola, which way does this open? Left and right. What are the intercepts?
2, negative 2, and
Just the x-intercepts. 4, right? 4, negative 4. And then to get the, you're right, to get the diagonals, you'd have to do every combination. Okay? So this is also a hyperbola. How do I recognize hyperbolas? We have a positive and a negative, right? If the x squared is positive, it's left and right. If the y squared is positive, it's up and down. That's my hyperbolas. Ellipses, they're both positive, right? Number 1, x squared term and y squared term are both positive. That's ellipses. Number 3, this is a parabola. We have y equals x squared, vertical parabola. If it was x equals y squared, horizontal parabola. You need to be able to do both on the test. Okay? Circle. right? I had to use completing the square to get this in perfect standard form for a circle, which is x minus h squared plus y minus k squared equals r squared. And don't forget lines. I didn't have any lines today, but anything like y equals mx plus b, anything where you have y and x, but there's no square term, right? Those are all lines. Those are all linear. You could also have just x equals some number or y equals some number. Those would be a vertical line and a horizontal line, okay? And you need to know all of these. Lines, parabolas, circles, ellipses, and hyperbolas. Question? Yes? Great. How do we tell the difference between an ellipse and a hyperbola? Yes? Right. Hyperbolas have one of the terms as negative. Ellipses, they're both positive. See in number 1 how they're both positive, x squared and y squared? That's ellipse. If one of them's negative, it's a hyperbola. Yes?
So negative y plus x squared, you want to switch it around so it's x squared minus y?
Sure. You always put it in this form. Yes. Okay? All right, you guys have a lot of studying to do because this is a big section on your final. Make sure you can graph all of these. All right, I'll see you next time.